Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on SCR protection. First, what are the protection methods here? First one is the over current protection, over voltage protection, dV by dt protection, di by dt protection, gate protection, and temperature thermal protection, temperature protection. This is one SCR. So for safe operation, so here we need to protect this SCR. While operating this SCR, we need to protect from the over currents, over voltages, and dV by dt, and from the di by dt, and from the gate protection, and from the thermal from the temperature also we can protect. So first, over current protection. So how you will protect the SCR from the over currents? So now SCR is having maximum highest voltage. There may beyond that limit SCR having some current rating. So if you give excess amount of current, so then here if suppose this is this current is rated current. So if you give over current to this SCR, so the SCR may damage. So how you will protect this SCR from the from the over current? Now here, so this is one fuse and circuit breaker. If you connect one fuse and circuit breaker, so whenever over current flows in this SCR, and fuse and circuit breaker will break, and so in this way here SCR will be protected from the over voltages. Next, over currents. Now what about over voltages? Over voltages here sometimes, so SCR can withstand with SCR can withstand with some amount of voltage. So if you give beyond that limit, so then the SCR may damage. So for that case, so we will give one special type of resistor. That one is a varistor. So now here, this varistor will protect from the over voltages if you give the beyond the specified limit. So now here, so what are the properties of varistor? If you draw the graph between voltage and current V and I, now here this graph should be like this. So now it offers at higher voltages, it gives low impedance, low resistance, and when it is low voltages, it offers high resistance. So now here, so this is the thyristor. So now here you give the supply. If you give over voltage, so if you give over voltage, and here over voltage means it offers low resistance. It offers low resistance means this resistive drop is low. So now here in this way, this SCR will be protected from the over voltages using varistor. So this is special type. It is having non-linear characteristics. The characteristics main properties here, for higher voltages it offers low resistance, means for lower voltages it offers high resistance. Now here another one, over currents can be protected from the fuse and circuit breaker, and over voltages can be protected from the varistor. And next, snubber circuit. Snubber circuit means here dV by dt protection. dV by dt can be protected by using snubber circuit. The snubber circuit means resistor in series with capacitor. So now here dV by dt means rate of change of voltages with respect to the time. So now here whenever dV by dt increases, so dV by dt increases means there may be a false triggering of this SCR. So false turning on method is the dV by dt. It is unwanted gate triggering. So now here in the SCR, P PNPN. So there may be, this is anode, this is cathode, and this one is a gate. Here there is a one capacitor and anode and gate, and from the gate and cathode there is a capacitance. Because of this capacitance, and there may be sudden changes in voltages, and there is a capacitance. So sudden changes in voltages and there is a capacitance means there may be transients occur, huge amount of current flows, and that current flows, that current is adds to this leakage current, and this thyristor is turned on. Unwantedly it is turning on SCR. So from anode to the cathode it will turn on. So it should not happen. Now using snubber circuit we can suppress this dV by dt, and now here C, this capacitor will bypass this dV by dt, and this R is the main purpose of R is it decreases the discharging capacitor current. And next another one is the di by dt protection. So here di by dt can be protected from the inductor. So inductor, if you connect the inductor in series with the SCR, then we can protect di by dt. So di by dt, so how it will happen? So when you give the positive, this is PN, and this is cathode, and this one is a gate. When you give positive supply to the anode and negative supply to the cathode, and if you give the gate, and then this thyristor will be turned on, and current flows from anode to the cathode. So now here this anode current it will take to spread in the inside of the SCR. So now here di by dt. So now here di by dt is greater than space charge velocity, the space velocity of charges. So space velocity of charges means here there may be hot spots create. That hot spots may that hot spots will damage the thyristor. So using inductor does not allow sudden changes in currents di by dt. Di by dt means rate of change of currents. Using inductor we can protect this SCR from the di by dt values. And next gate protection. So now here this RG is will decrease the gate current, and next this G node, this is IG. So it will control the RG. This resistor will control the IG current, and next here Xenodiode. Xenodiode will control this gate cathode voltage, so it will maintain the constant voltage. Here what about this C and this capacitor and this R, parallel capacitor and parallel resistor and capacitor will reduce the unwanted noise from the gate signal. So now here this is R capacitor in series with resistor, here capacitor in parallel with resistor. In this way SCR will be protected from the heat, from the temperature. We will protect from using heat sinks, we will connect it here. So now here over voltages can be protected from the fuse and circuit breaker, and di by dt can be protected from the inductor connected in series, and over voltages can be protected using nonlinear resistor, that is varactor. And next snubber circuit main purpose is it will protect SCR from the dV by dt. And next here this main purpose, this xenodiode and this resistor, and these are protected from the gate, protect the SCR from the gate. And next here heat sinks are used to protect the SCR from the thermal temperature. So this is regarding protection of SCR. So now here these are the problems. For first one is calculate the required parameter for sub-snubber circuit to provide dV by dt protection to SCR used in a single phase bridge converter. So the SCR has maximum dV by dt capability of 60 volts by microseconds, and the input line to line voltage has peak value of 425 volts, and the source inductance value is 0.2 2 millihenries. So now solutions for this one here. First dV by dt. So now this is dV by dt is 60 volts per microseconds. And here another parameter is given 0.2 millihenries and the maximum voltage is 0.425 volts. So now here the formula for capacitor number circuit R and here C. So now here this is thyristor. So now snubber circuit, this is R and C. So the C equals to here 1 by 2L 0.564 Vm by dV by dt whole square. And now here L equals to 0.2 millihenries. This is millihenries and 0.564 into 425 by 60 into 10 power minus 6 whole square. This is the voltage Vm and 60 into this is dV by dt 60 into 60 volts by 60 volts per micro means into 10 power minus 6. So now the value of capacitor C value equals to 0.04 microfarad. And next second one is R value. So R value equals to 2 sigma square root of L by C. Here sigma equals to 0.65. Assumption that is damping factor, and this is L value and this is C value and this is sigma, this is L and this one is C. So now the final value is R equals to 92 ohms. So now the required parameter for submer circuit are resistor and capacitor. Resistor value is 92 ohms and capacitor value is 0.04 microfarads. And next second question is here, calculate the value of snubber circuit components in the figure to protect SCR from the applied dV by dt if dV by dt rating of SCR is 100 volts per microsecond. So now this is the circuit diagram. This is SCR. This SCR can be protected from this snubber circuit. This is snubber circuit. Snubber circuit R and C connected across this L. Now here L equals to, this is L equals to 0.1 millihenries and this resistor is a R, and next supply voltage Vm equals to 500. We know the formulas for C and L. C equals to here 1 by 2L, so 0.564 Vm by dV by dt whole square. So now if you see this one, so this is L 0.1 millihenries and Vm equals to 500 volts and dV by dt equals to 100 volts per microseconds, 100 per 10 power minus 6 volts per. So this is not micro. And next here C equals to formula 1 by 2L 0.564 Vm by dV by dt whole square. So now this is a L value and this is a V value and this one is a dV by dt. L, Vm and this is dV by dt. 100 by 10 power minus 6. And this value equals to 0.04. So now this value equals to 0.04 microfarads. And next second one is here R. R value, what about R value equals to 2 sigma square root of L by C. So now here what is the 2 sigma? Sigma means damping factor square root of L by C. So now here this 2 equals to 0.065 square root of, so this is L and this one is the C. So now here damping factor equals to 0.65 already. Now this value equals to 65 ohms. So now here, so already here 25 ohms are connected in series here. So now out of this 25 ohms is already present in the circuit. So now here this R equals to 64 minus 25. So that equals to 40 ohms. And next here, second one, next problem here. An SCR operates from 300 volts, that is Vm is equals to 300 volts and it has series inductance, so that L equals to 4 microhenries into 4 into 10 power minus 6 henries. So the resistance of 4 ohms and capacitance is 0.2 microfarad is connected across the SCR. So calculate the dV by dt and di by dt ratings of SCR. Reverse question. So now here I am drawing. So the circuit, the resistor and capacitor are connected across the SCR. So now inductor is connected in series and the supply voltage is Vm equals to 300 and this is 0.4 microfarads and this R and C values are given 4 and this is 0.2 microfarad. So now here the values of inductor di by dt protection. So how you will, so we know that Vs equals to L di by dt. Here inductance value equals to L equals to 4 into 10 power minus 6 and Vs equals to 300 volts and di by dt value you can calculate easily. So now this di by dt equals to here 300 by 4 into 10 power minus 6, that means 75 ampere for microseconds. And next here, so here the value of snubber circuit capacitor, so we know this formula very well. So now here C equals to, so what is the value of C? Here C value equals to 0.2 into 10 power minus 6. So that equals 1 by 2. This is the L value. So 0.564 into 300 by dV by dt. From this calculate dV by dt. So now here that value equals to 133.76 volts per microseconds. So now this is the case. And next problem here, so SCR has di by dt that equals to 120 amperes per microseconds and a dV by dt of 300 volts per microseconds. So it operates on 250 volts DC with a load resistance of 10 ohms and find the snubber values. So snubber circuit parameters for components of the snubber circuit. So now here if you draw the circuit, so first draw the circuit. Here this is the thyristor SCR. So now here this is R and this one is a C. R and C. Here this is supply voltage. So 250 volts DC. And next here there is a inductance value is not given. Okay. So now here the load resistance is 10 ohms. Now here, so L value equals to, how we will calculate the L value equals to, so di by dt is given. So di by dt is given. So Vm equals to here what is the value of 250. 250 by, so di by dt equals to 120 into microseconds means here into 10 power 6, that value equals to L equals to 2.08 micro henries. So now here L value we calculated, and next after getting L value only we can calculate the C and R value, R and C value, then only we can calculate the R and C values. So now here 1 by, this is L value, so C equals to 1 by 2L 0.564 Vm by dV by dt whole square. So this is the, so this is Vm and this one is the dV by dt, 300 volts by microseconds. So now here 300 into 10 power 6 and that value equals to 0.053. So this value equals to 0.053 microfarad. So now what about the R value? So now here R value can be calculated by using this formula. So now here this value equals to 2 into damping factor sigma and square root of inductor L by and C. So now the damping factor always 0.65. So now here the load resistance value is already given, R plus 10 equals to, so the damping factor is sigma and this is the L value is calculated and this is the C value we calculated, C value. Now here the R value is the minus 1.856. So now this. So I hope all these problems, so the protection of SCR, it is clear too. So now here SCR can be protected from the over voltages, over currents, dV by dt, di by dt, from the thermal, from the gate. So here we can protect. Over voltages can be protected from the varistor across the SCR, and over currents are protected from the fuse and circuit breaker connected in series, and di by dt can be protected from the inductor. Inductor does not allow sudden changes in currents. And next, dv by dt, from the dv by dt we can protect SCR by using snubber circuit. Snubber circuit is always resistor in series with the capacitor. And next here, from the gate, so here gate current can be controlled by using RG. And next is the Zener diode, maintains the constant voltage across the gate and cathode. And R and C parallel connection avoids the unwanted noise from the gate. And next, heat sinks provide heat sink protected the SCR from the thermal. So this is regarding protection of SCR and related problem. I hope all these problems and this protection is clear to you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.